stations 1, 2, and 3 in this video. Hopefully I can make it through all of them. And first 3 stations, wow, look at this. All of them deal with Lewis structures and covalent bonding. Well, actually, and Lewis structures right there as well, too. H2. H should be very easy for you to think about because it's got 1 valence electron. There you have that. Oh, yeah, no, that's right. CH4. 1, 2, 3, 4. Well, you know that H bonds to any single bonding site, right? I mean, how many more times can we do CH4? It's like some of these are just like that. At this point, should just be memorized. H2O and H3, those can all be memorized. Let's try H2O2. 1, 2, 3, 4. Let's do, how should we do this one? We could do it like this. 5 and 6. And then 1, 2, 3, 4, 5, and 6. There's a bond right there. There's O2, and we need an extra bonding site for the H's. So there you go, H2O2. You can do it like that. You can also do it like this. This is fine too, perfectly acceptable. Okay, what I'm about to draw is fine as well. That's also fine. That's probably actually better. It would probably look more like this anyway. Either or is fine. H2O. 1, 2, 3, 4, 5, and 6. And then put your H's there. NH3. 1, 2, 3, 4, and 5. Silicon tetrahydride. Hold on one second. I had to get my periodic table just to show you. Silicon is in the same group as carbon, which means it's going to have 4 valence electrons and therefore 4 bonding sites. So silicon is going to look like that as the central atom, Si. And then you got 4 hydrogens. 1, 2, 3, and 4. There you go, SiH4, done. That's station 1. Station 2 says the following. Consider the following Lewis dot symbols. Circle the elements and electrons that follow the octet rule. Example. So the idea is this. You want to look at, well, and then they give you, the first example is not very good anyway because hydrogen doesn't follow the octet rule. But carbon does. Hydrogen's only got 2 seats, remember? If you were to draw the Bohr model for hydrogen, it would only have 2 seats. Okay? So these are this particular hydrogen is sharing these electrons. This hydrogen is sharing these 2 electrons, etc. And then the carbon is sharing all 8. Okay, so with nitrogen, let's have a look. Just start counting electrons. 1, 2, 3, 4, 5, 6, 7, 8. So this nitrogen is sharing these electrons. And this nitrogen is sharing these electrons. Here we go. Carbon has 8 surrounding it. 1, 2, 3, 4, 5, 6, and also these. It doesn't matter that they're over here. That is irrelevant. The way we group these is around this carbon. There's the 8 closest to that carbon. Hydrogen has 2. This hydrogen also has 2. Oxygen has 8. 1, 2, 3, 4, 5, 6, 7, and 8. H2O, well, all 8 of these are surrounding the oxygen. This hydrogen is sharing these 2, that hydrogen sharing these 2. NH3, again, all 8 of these are surrounding the nitrogen. That hydrogen shares those 2. Every hydrogen shares 2. Silicon tetraphosphide. let's see. I'm sorry, phosphide, fluoride. Silicon tetrafluoride. Okay, 2, 4, 6, 8, around that. And then this fluorine has 8, as do the other 3 fluorines as well. That's how you do that. Okay, very simple. Let's move on to the next one. Station 3. Draw the Lewis symbols of these compounds. N2O2. Okay, well, let's just do it. N2 looks like this. Share, and then we can share that other one. So if I were to draw it cleanly, here's what I would do. Okay, O2. By the way, I already have all these memorized, or most of them at least. I'm just working them out here for your benefit. I'm going to write them more cleanly below, like I did here. O2. So to clean it up, okay, you can work it out. This is how you would work this out, and then to clean it up, you go like this. Okay, C2H2 looks like this. Figure out where the H's go. You can pick any spot you want for the H's. It doesn't matter. Oops, C2. See, I already messed that up. That's why you don't. It's better to use a pencil. Alright, so now that gives us 1, 2, 3 bonding sites for each carbon. That means it's got to go like that. Okay, I'll clean it up down here. There you go. C2H2. C2H4. Just pick 4 places to put H's. 1, 2, 3, 4. That gives us 2 bonding sites left for carbon. So carbon with a double bond. I'll draw it down here. Hopefully you guys can see it. Carbon with a double bond. And then 4 H's. Okay. CH2O. Carbon's your central atom. Here's what I would do. I would just go in order. CH2O. You're going to have to use 2 H's here. And now you've got an oxygen down here that's got 2 bonding sites as well. So that works out very nicely. CH2O. Okay, and I don't need to clean that up anymore. That's what it would look like. CO2. Again, CO2. Here's a hint, guys. It keeps showing up over and over again. CO2. Should just have it memorized. Should be able to do it from memory at this point. Okay. 1, 2, 1, 2. Clean it up, please. That will not be acceptable. So clean it up. It would look like this. C double bonded to O, double bonded to another O. Put your lone pairs on the oxygens. Okay, and that concludes station 3. Next video will be 4 through 7.